Over the last 20 years, California has led the way in the solar industry, starting with the installation of a 345 megawatt solar thermal system in the Mojave Desert. Harnessing energy from the sun using solar PV technology will allow us to rely less heavily on fossil fuels and other non-renewable forms of energy. However, as climate change progresses, it is imperative to know exactly where these solar installations should occur in order to most efficiently capture solar radiation with installed solar systems. So far, most solar installations in California have occurred in Southern California, specifically Los Angeles, San Diego, and Riverside counties. Installations are expected to spread farther north to Tulare, where a 60 megawatt system is already planned for construction over the next couple years. Here at USF in the Geospatial Analyst Lab, I have analyzed the solar radiation predicted to occur throughout California from 2016 to 2099. These future estimates were based on 4 different climate change models, each with 2 different emission scenarios, displaying the worst and best case scenario. The solar radiation data was collected from CalAdapt and used to create raster maps displaying the changes in solar radiation over the next 83 years. By using ArcMap's model builder, zonal statistics were calculated on the solar radiation of each county, separated by model and emission scenario. The models were compared to reveal relatively little variation in resulting data. Emission scenario B1 predicted higher solar radiation limits in developed countries with greater air pollution and higher industrial activity, likely due to the predicted phase out of fossil fuels, replaced by renewables that eventually will lessen the air pollution in these areas, causing more direct sunlight to reach the Earth's surface. With the increasing efficiency of solar modules, California should be able to reach the emission standard of 33% renewables by 2020 and 50% renewables by 2050, if not earlier. Currently, 13.4% of domestically produced electricity comes from renewable sources. Of this 13.4%, solar accounts for 4%. With the amount of solar radiation we are expected to receive in the coming years, it is imperative to strategically install solar systems throughout areas of California with the most solar radiation in order to increase the renewable percentage of energy to 33% by 2020. Examining the maps created from the CalAdapt raster data, it can be seen that expanding the solar industry to the Central Coast in Northern California would allow solar systems to harness the most energy. Although the change is slight, these areas seem to be gaining the most solar radiation in the coming years. The extreme differences in weather by county prove to be correlated with the climate change patterns, where yearly variations in places like Alpine are dramatic, while in San Diego there is a consistent greater solar radiation with little variation. Limitations of the study surround the uncertainty in the climate change models and emission scenarios. I chose to collect data on all 4 emission scenarios to compare the differences in the results. All 4 models seem to follow a similar trend, with CCSM showing the most difference between emission scenario A2 and B1. For this reason, I chose to focus most of my analysis around the CCSM climate change model, which represented an overall increase in solar radiation throughout each county. In conclusion, the analysis of predicted solar radiation from 2016 to 2099 showed little variation between climate change models, with a general slight upward trend. Counties in Southern California have always had consistently high solar radiation levels, which are predicted to continue in the future. However, counties in Central and Northern California are predicted to experience higher solar radiation levels and should be considered as ideal locations for future solar installations.